Kia ora, Year 11 and 12. I'm going to start making some revision videos on different topics, and I'm going to start with vectors. So in each video, I'm going to pick out a couple of the key skills. So these are not going to be old exam questions. They're going to be the basic skills. I'm still going to do videos for worked solutions from harder exam problems. The two skills in this video are how to find the distance of a point from a plane and how to find the distance between two planes. So this is the first question I'm going to look at. How do we find the distance between this point here and this plane? Right, so the fastest way to do this is to remember the lovely formula for the distance between a point and a plane, and it goes like this. That distance d can be written as follows. And you'll see different versions of this formula. As usual, the main thing is that you understand what it's about. And this is one that I don't think you get on the formula sheet, but it's very easy to remember. So the ends in here come from the normal vector to the plane. And I've labelled that N1, N2 and N3. And the x0, y0, z0 is the point. So in this case, we've got the normal numbers. The n numbers are coming from here. The k is this, and the x0, y0 and z0 are this. So here, what's my distance between the two things? Well, I've got 2, -4, -1, and 2x minus 3y plus 6z is equal to -1. So the distance from the point to the plane goes like this. It's the absolute value of 2 times 2 plus -3 times -4 plus 6 times -1 minus the constant in my plane equation, so minus -1, divided by the magnitude of the normal vector. So that's 2 squared plus -3 squared plus 6 squared. So let's see what that gives us. We'll see if they work out to be nice numbers. So we've got 4 plus 12 minus 6 plus 1 over 4 plus 9 plus 36. So the denominator is nice because it's the square root of 49. The top line is 17 minus 6, so 11 over the square root of 49, which simplifies to give me 11 over 7. Okay, so that's how we find the distance between a point and a plane. So that's one that you need to make sure you've practiced so you can make up a couple of examples for yourself. The point and the plane don't have to be anything special. You might want to try one where the point is in the plane and make sure that you get 0. That's a good one to try. And now I'm going to look at how to find the distance between two planes. Right, so the first thing to think about here is that if we've got two planes that intersect, then obviously at some point the distance between them is going to be 0. So this question is really only meaningful where the planes are parallel. So the first thing you want to check when you're looking at this is what's the direction vector of each plane. Now in this case it's really, really obvious because I've made it like that the direction vectors are the same. But suppose we had instead check this equation against this one. So 2x plus 4y minus 4z is equal to 20. Well, you'd want to first of all have a look at the direction vector here, which is 2, 4 and -4, and the direction vector here 1, 2 and -2. So this one is they're scalar multiples of each other. Okay, so we can only really make sense of this question when the two planes are parallel. Otherwise they'll meet somewhere and the distance between them at that point will be 0. So here we've got two parallel planes. So just picture that. Right. Here's one plane and here's the other plane. So what am I trying to find? I'm trying to find the distance between the two of them. Right, and that will be where there's a perpendicular formed here and here. So how am I going to do it? Well, what are my two planes? Well, two planes that I gave you were, where's my bit of paper? X plus 2y minus 2z equals 3. And x plus 2y minus 2z is equal to 10. Now, don't be tempted to think that the distance between them is going to be 7. It's not quite that simple, right? But what we can do is use the skill in the first half of the video, which is that we can find an arbitrary point on one plane and then figure out how far it is to the other plane. So finding an arbitrary point is really easy because we're just going to choose to set two values equal to 0. And in this case, I'm going to let y and z equal 0 and then see what the x value has to be for a point to lie on that plane. So we get x plus 0 minus 0 equals 3. So the point on P1 is 3, 0, 0. Right, so this one's P1 and this one's P2. So now that I've got this very simple point on plane 1, I'm going to use my distance formula to see how far it is from P2. So D is going to equal 3 times 1 plus 0 times 2 minus 0 times 2, take away 10, divided by the magnitude of the normal vector in P2, which is this, so 1, 2, negative 2. So let's see what that gives us. Well, that gives us 3 take away 10 over the square root of 1 plus 4, which is root 9, which is 3. So we get the absolute value of negative 7 over 3. So the distance between the two planes is 7/3. Okay, thanks for watching. I'm going to do some more later on. If there are any specific vector skills that you are worried about, just send me an email and I'll focus on those next.